My name is Bill Farmerie. I'm the Associate Director of the Interdisciplinary Center for Biotechnology Research. We abbreviate that ICBR. At the University of Florida, one of the biggest things that we do is DNA sequencing, and of course in the most recent years it's been next generation DNA sequencing. The majority of clients are on-campus research scientists. We also do work for the biotech industry in the state of Florida. About 4 years ago, we recognized that the ground was shifting in DNA sequencing. At that time, one of the first of the next-gen instruments was arriving on the market. While it was very early, we made that decision to try to get into next-gen sequencing. We could see that the productivity and the cost efficiency of next-gen instruments was going to transform how we thought about doing biological research. After a couple of years, things were shifting again. A different style of next-gen sequencing, what we call short-read instruments. That's when we started to think about what was Applied Biosystems doing. From an instrumentation point of view, there were a couple of things about Solid that helped me decide that this was the direction that we would go in. I felt that they had a very workable, very diverse strategy for doing mate pair sequencing, and I thought mate pairs was going to be a really big thing in the applications and that we would use that a lot. The other thing is that Applied Biosystems just has a reputation of making technology work. They have a very powerful technical infrastructure, development R&D infrastructure at Applied Biosystems. When we put a question to them, yeah, they come back with an answer. And that customer service aspect, that's a big part of your confidence that you can pull this off. One of the things that we foresaw when we began to think about using a short read instrument is that the range of applications for Solid, for short read technology, was something that was going to be expanding. That once you put the technology in the hands of the research community, you begin to find new ways to use it, ways that you never imagined that you could use it. The things that we've looked at were ChIP-seq, bacterial genome resequencing. We did some early on RNA-seq, and then lately we've been doing a lot of human genome resequencing. People are intensely interested in looking at genomic rearrangements in various kinds of cancers. There's a tremendous amount of interest right now, big buzz, about doing RNA-seq. It's the thing that I think that we're focusing on for the next set of projects. Our role in the research process is to provide these tools to the individual investigators. We look at ways that we can use technology to solve the questions that they're trying to get at. Right? We can bring it so far, but that last mile, that eureka moment, this is where they use their intellect, their knowledge of the specific knowledge of the system that they're working on, to make the last connection between the information that we've produced for them and really the end of the discovery process.